Hello, my dear student. Welcome to another edition of your mathematics lesson. Today, in continuation with your main topic, that is longitude and latitude. What you are going to learn today is how to find the distance along a greater cycle. So let's begin. After completing the very lesson today, my dear student, will be able to find the distance between the 2 points that happens to be on a greater cycle. This is what I hope you'll be able to do, my dear student, after completing the very lesson today. So as usual in every favorite segment of the lesson, Mercy Stefan, today, my dear student, I'll give you another interesting number. Of course, this number is so large, but it is indeed interesting. I'll give you what is interesting about this very number after completing my lesson today, so don't go away. To begin the lesson, my dear student, let us first know what a greater cycle. Greater cycle refers to either longitudes, that is, all longitudes are greater cycles. Similarly, latitude 0 degree, that is equator, is another greater cycle. These are the two things that we refer to as greater cycles. All greater cycles have radius equals to the radius of the earth, and that is usually denoted by capital letter R. So let us move and learn how to find the distance along greater cycles, that is distance between 2 points that happens to be on a greater cycle. So to begin, let's just consider these 2 points x and y, and these 2 points x and y. As you can see in these different diagrams here, you can see here this first diagram, the point x and the point y happens to have also happens to be on the same longitude. Look at the longitude here. The 2 points in the second drawing also, x and y, happens to be on the same longitude. Look at it. And looking at the 2 points x and y in the third drawing happens to be along equator. Look at it, 0 degree latitude. So it is this distance that we would like to find between those 2 points. So whichever drawing that we're going to take, the distance between those 2 points, whatever drawing, the distance between those 2 points will now be nothing but the length of the arc, xy. Look at the xy, the arc xy in blue. Look at it. In the second drawing, look at the arc xy also in blue. In the third drawing, look at arc xy also in blue color. So whichever this drawing, the length arc, that is the length of the arc xy, will now be nothing but this very formula, theta over 360 multiplied by 2 pi r, where r is the radius of that very cycle. And the theta would now be difference in either latitude or difference in longitude. It depends on the case. In case 1 and 2, that is diagram 1 and 2. So this angle theta in case 1 and 2 will now be difference in latitude. But in the third drawing, the 2 points x and y happens to be on same latitude. Therefore, the angle theta, angle subtended by that arc xy at the center of the cycle, would now be difference in their longitude, because they have different longitudes in this case. So that's why I say the theta will now be difference in either latitude or longitude, as the case may be, while r, capital letter R, refers to the radius of the earth, and the pi is a constant value usually given in the question as 22/7 or 3.142. But this angle theta, how we obtain this angle theta, may differ from these different drawings. In the first drawing, the angle theta, look at it in the first drawing, where we said angle theta is this angle subtended by arc xy at the center of that very longitude. How we obtain this angle theta is simply addition of the two latitudes. So we now add the two latitudes there to get the angle theta. So theta in this case will now be alpha, the latitude of x, plus the latitude of y, because the two happens to be on different hemispheres, that is north and south. But if you move to the second drawing, the 2 points x and y have latitude alpha north and beta north. You can see here is same hemisphere. Therefore, the angle theta in this case will now be higher latitude minus the lower latitude. So we now subtract the beta which will now be lower latitude from the higher latitude. But looking at the third drawing, that is if the 2 points happens to be on same equator, which means they have different longitudes. So here, as you can see, this longitude is east and the other one is west. So there also, to get a theta, what we do also is to do addition of the two longitudes, that is alpha and beta. But in case this x and y happens to have longitude which are on both sides, either all east or all west, so there also you did the subtraction as we did in this drawing number 2. So this is what we now used to find the distance between the 2 points that happens to be on great cycle. These are the 3 different cases for us to have 2 points on great cycle. 3 different cases. So let's just move and take examples. Example number 1, it says 2 points x on this latitude, 30 degree north and 50 degree east longitude. Another point y having this location, 10 degrees south and 50 degree east longitude. These 2 points are points on the earth surface. The question asked here is to find or calculate the distance between x and y along the great cycle. The great cycle here is this longitude 50 degree east, 50 degree east. So the 2 points x and y happens to be on same longitude, and that longitude is 50 degree east, as you can see in the question. So what we do first is to have a sketch of those 2 points on the earth surface. So let me just have a sketch of my earth. A sketch of my earth, look at it. This is the sketch. So what I'll do, I'll first locate on this very point x. The point x happens to be on the latitude 30 north and 50 east. So let me start drawing the longitude 50 degree east. Look at it. This is my longitude 50 degree. I'll now draw this latitude 30 north. 30 north, let me draw it somewhere here. This is latitude 30 degree north. And this point will now be my point x, where the 2 lines crosses, longitude 50 and the latitude 30 degree north, where the 2, that will be the location of the point x. So I move to locate the second point y. Y is on same longitude 50 east. I have it already. So what remains is to sketch this latitude 10 degrees south. So let me go somewhere and draw my latitude 10 degrees south and where this latitude crosses this longitude will now be the position of the point y. So therefore, if I continue to find the length or the distance between those 2 points along that great cycle, that very longitude will now be nothing but the length of this very arc. Let's say the arc, it is this arc in blue, and that arc obtain an angle theta at the center of that very longitude. So therefore, the length of this arc will now be nothing but theta over 360 multiplied by 2 pi r, where r is the radius of that very longitude, which would now be something as the radius of the earth. You can look at it. And the angle theta is the angle subtended by that arc at the center. And if I look at this now, the 2 points happen to have latitude north and south, so it's different hemispheres. So to get my theta, what I'm going to do is to add the latitude of x plus the latitude of y. So I have 30 plus the 10. That gives me 40. That will now be the angle theta. So I can now substitute, because I have r already in the question as 6,400 kilometers, and the pi is given in the question 3.142. So I'll now substitute in this simple formula. My theta is 40. So I'm going to have 40 over 360 multiplied by 2, multiplied by the pi, which is 3.142, multiplied by r, which is 6,400 kilometers. So simplifying this correctly, you now have your final answer to be 4,468.62 kilometers as the distance between these 2 points x and y on the earth surface. So let us move and take another example. Example number 2, it says 2 points A and B are both on longitude 100 degree west. And the 2 points have latitudes 80 south and 35 south respectively, which means A is on latitude 80 degrees south and the point B is on latitude 35 degrees south. The question asked is to find the distance between those 2 points A and B along that greater circle, meaning along that longitude, common longitude, that 100-degree west. So what we always do is to have a sketch of those 2 points on the Earth surface. So let me draw my Earth. If assume this is my Earth, then I will now draw that common longitude, which is 100-degree west. Let me have it like this. This is my longitude, 100-degree west. Then I'll locate B. B is on the latitude 80 south, so let me have that 80 degrees south latitude. Look at it. So this will now be point A, where the latitude and the longitude crosses. That very point is the position of A on the Earth's surface. Then I'll move to locate the position of the point B. This is the point B, and the B is on latitude 35 degrees south. So I'm going to draw another latitude somewhere. Look at the latitude 35 degrees south. So it should be on top of this 80 because from the equator, as you are moving down to the south pole, the angle of that latitude keep increasing. So as this angle 35 degrees is smaller than 80. So which means latitude 35 degrees south will now be somewhere here on top of this 80, not below it. So let me just draw it 35 degrees south. Assume this is my latitude 35 degrees south. So where that latitude crosses longitude 100 degrees west, that will now be the position of the point B. So to find the distance between A and B that happens to be on this longitude 100 degrees west, what we simply do, that distance would now be nothing but the length of the arc AB. Arc AB, look at AB. Let's see that arc clearly. Look at the blue line here. The blue line here signifies the arc AB. And the length of that arc will now be the distance between A and B on the Earth's surface. That arc subtend at angle theta, and the radius of that very longitude is not the same thing as the radius of the Earth. So let's just substitute in the formula or write down the formula. So the formula for length of arc AB would now be theta over 360 multiplied by 2 pi r. But in this case, the theta, to find the theta, remember, if the 2 points happens to be on same hemisphere, that is point A is in the southern hemisphere because it is latitude is 80 degrees south. And the point B is also in the southern hemisphere because it is latitude is 35 degrees south. So what we now do to get that very theta, the rule tells us that we subtract the smaller latitude, which is 35, from the higher latitude, which is 80. That will give answer theta to be equals to 45 degrees. So this is the theta that I'm going to use here as 45. Other variables pi and r are given in the question, so I'm just going to substitute. So substituting there, I'm going to have 45 instead there's a theta over 360 multiplied by 2 multiplied by the value of pi asked to use in the question is 22 over 7, then multiplied by capital letter R, which is given in the question as 6,400 kilometers. So this is my substitution. So simplifying this correctly will give a result 5,028.57 kilometers as the distance between A and B along the Earth's surface. So this is the distance between A and B. Let's just move and take another example. Example number 3 says two cities K and L are on the equator and on longitude 60 degree east and 12 degree west respectively. The question asked is to find the distance between K and L along that great cycle, along that very common equator. Solution to this, so what we do, we sketch our Earth and we sketch that very equator that the 2 points K and L happens to be on that very equator. Remember, equator is 0 degree latitude. But the longitude of K is 60 east. So let me start with that longitude 60 east. This is longitude 60 east. So where the two crosses will now be the position of K. Then the other point L is on longitude 12 degree west. So 12 degree west, let me sketch it also. This is my 12 degree west, so where that longitude crosses the equator will now be the position of air. Then the distance, this KL would now be nothing but the length of the arc KL. Arc KL, and that arc KL is given by the formula theta over 360 multiplied by 2 pi r. So in this case, the 2 points happens to be on equator. Then the angle theta will now be difference in their longitudes, and these longitudes happen to be in different hemispheres, that is east and west. So we now add the two longitudes to get this angle theta. So theta will now be the longitude of K, 60, plus the longitude of L, which is the 12. That will give me my theta, and that addition correctly will be 72. So I'll now substitute. Already I have the R and the pi in the question. So substituting, I will now have K to be 72 over 360 multiplied by 2 multiplied by 3.2142 multiplied by 6,400. And simplifying this correctly will now give the distance to be 1,043 kilometers, 0.52. This is now the distance between K and L. So with the few examples given, I hope my dear student will be able to find the distance between any 2 points that happens to be on a grid cycle. Thank you for your attention, and let me just move to the last segment. Maths is fun, and I explain what is interesting about that number 12,345,679. What is interesting about this very number? This number is large, but the quick way to identify this very number, it contains all the numbers from 1 to 9, with the exception of the number 8. 1, 2, 3, 4, 5, 6, 7. You can see 8 is missing, then 9. So it is all the digits from 1 to 9, with the exception of 8. So this is a quick way to identify this very number. This number is so special because multiplying this very number by 9 or by multiple of 9 will now produce what we call a rep digit, meaning a number or a result that contains same digit repeatedly appear. Let's just start. Multiplied by 9. This number multiplied by 9 gives a result 111, that is 111 million. 111,111. This is what you have after multiplying this by 9. If you now take another multiple of 9 and multiply the same number by that multiple of 9, let me just take 18. 18 is multiple of 9. Multiplying this by 18, you have another rep digit, that is a result containing just the same digit. And this is what you are going to have if you use your calculator. So you have 222 million, 222,222. This is what you have. If you take another multiple of 9, that means said 27, and multiplied by this number, this is what you are going to have 333,333,000, then 333. Let me just take one more. Multiplied it by 36. 36 is another multiple of 9. And this is what you are going to have if you use your calculator, is another rep digit. This is really amazing. It's really surprising. We see more of this result, more of this amazing things in our subsequent lesson. Thank you for your attention.